Hey scholars, I hope this video finds you well. For this lesson, we're going to be discussing solving quadratic equation. Last week we talked about factoring quadratic expressions. We're going to take it a step further and solve quadratic equations. So make sure to take good notes and follow along. I'm actually going to be working at my whiteboard today, so hopefully you like that a little bit better. I know I do. But let's go ahead and get going. Alright scholars, so I'm back to kind of teaching the way, at least a little bit of the way I taught last year with the slides on the whiteboard. These slides will be found on Google Classroom if you want to follow along with me, and I highly suggest you do. Let's move forward. So here's an example that you'll find on your Google Classroom slides of how to solve simple quadratic equations. And when we solve quadratic equations, we find the roots, or what we call the solutions of the equation. So here we have this problem where we're trying to solve this equation 4x minus 20 equals 5. So when we're trying to solve these quadratic equations, our goal is ultimately to isolate x like we solve any equation. So what I'm going to do first is add 20 to both sides of the equation. So then we get 4x squared equals 25. And then my next step would be just to divide both sides by 4, because remember, we're trying to isolate x, and then we get x squared equals, that's just going to be 25 over 4. We cannot simplify that fraction any further. Or if you wanted to write it as a decimal, you could say 6.25. But we're going to keep it as a fraction. So now my goal is to get x by itself. But if we have an exponent right here, the way we're going to do that, the way to isolate x, is to square root that giant. Alright, we're going to square root both sides of the equal sign. Okay, whatever you do to one side, you have to do the other, right? So the square root of x squared is just x. The square root of 25 is 5, and then the square root of 4 is 2. Now, we're not done yet. We're almost done, but 5 over 2, or 5 halves, is not the only solution. When we have x squared, so we had 4x squared minus 20 equals 5. That was the original problem. This 2 right here, we'll talk about this more in the future, but that exponent of 2 is called the degree, and the degree tells us how many solutions we're going to have. Well, since the degree is 2, we're going to have 2 solutions. So 5 halves is one of the solutions, but we have 2 solutions. So what we're going to actually say is positive or negative 5 halves. That's positive 5 halves and negative 5 halves. We have 2 solutions, and here's why. If I substitute positive 5 halves into this equation, oh, that's squared, right? I'm going to get 4 times 25 over 4 minus 20 equals 5. Well, 4 times 25 over 4, what's going to happen is that's just going to cancel. And we end up getting 25 minus 20 equals 5. So 5 equals 5. That checks out. So positive 5 halves works here. Now, if I change that to negative 5 halves, well, negative 5 halves squared is still positive 25 over 4. Negative 5 halves squared is positive 25 over 4, because a negative times a negative is a positive, right? So, again, same thing would happen. The 4s would cancel out. We get 25 minus 20 equals 5. 5 equals 5. It checks out. So, when you square root that giant, like we did right there, you're left with a positive answer and a negative answer. There's 2 answers. So x equals positive or negative 5 halves. Now, I'm going to clear the board, and we're going to look at number 2. So I want to solve this one here. So again, I'm trying to isolate x. So I'm going to add 6 to both sides of this equation. Negative 6 will cancel out right there, so I'm left with 2x squared equals 22. We're going to divide both sides by 2. That'll cancel. We get x squared equals, what's 22 divided by 2? Well, it's 11. So x squared equals 11. So then I'll just square root that junk. And I cannot take the square root of 11, so I'm just going to leave it under the radical. We get x equals the positive or negative square root of 11. Remember, include that positive or negative in your answer. So voila, there we go. Okay, so now let's try these problems. We want to find the roots of each equation or the solutions of each equation by factoring. So we're just trying to solve for x just like we were in the last problems. But I can see that I can factor from this binomial. Binomial meaning two terms. Okay, so from the x squared and the 3x, I can factor out a greatest common factor of x. So I get x times x plus 3 equals 0. So now, here's the next step that's very important. We're going to break these two expressions on the left side. We're going to break them apart. So you'll see what I mean here in a sec. I'm going to say x equals 0 next. X equals 0, and then x plus 3 equals 0. So now I've broken these up into two different equations. Okay. So x equals 0, there's nothing else I need to do here. X just equals 0. That's one of the solutions. If I substitute 0 into the original equation, I'll get 0 squared is 0, plus 3 times 0 is 0. So 0 plus 0 equals 0. That checks out. Okay. So one of my solutions is 0 for x. Now I'm going to subtract 3 on both sides for this little equation. And we'll get x equals negative 3. So I have two solutions here. X equals 0 and x equals negative 3. Again, we can check this. Negative 3 squared, just substituting in here, negative 3 squared is 9. Negative 3 times negative 3 is 9. Plus, well, 3 times negative 3 is negative 9. So 9 plus negative 9, it's like saying 9 minus 9, which is 0. So that checks out as well. So both of these solutions check out. So I can write them all in one place. I'm going to say x equals, and I'm just going to go least answer, the smallest answer, first. So negative 3 is less than 0. I'm going to write that first. So negative 3, 0. Those are my two solutions. Remember, the degree was 2. Those are my two solutions. Negative 3 and 0. And if you said 0 and negative 3, that would work. That would still be correct. Okay? So let's move on to problem number 2. X squared minus 3x, x squared equals negative 3x minus 2. So in the first problem, it was every term was on the left side and just 0 was on the right side. Okay, so it's hard to know what to do in this equation. We really want the equation to be in the form ax squared plus bx plus c. So in this case, in number 1, a was 1 and b was 3, and just c was 0, plus 0 right there. But in this case, we just have ax squared, where a is 1 right here. The coefficient of x squared is 1. That's on the left side. So I want to bring these terms over to the left side with it. So I'm going to add 3x on both sides. So plus 3x, and I'm going to add 2 on both sides. Plus 2. So that's going to get me x squared plus 3x plus 2 equals 0. Because all this is going to cancel out over here. Well, now it's in ax squared plus bx plus c form. And I can see that I can actually factor this. Well, what are the factors of 2 that will add up to 3? Well, you got 2 times 1. 2 times 1 is 2. 2 plus 1 is 3. So I'm going to factor this as x plus 1 times x plus 2 equals 0. Now, there's a quick way we can try to solve this. I can just say, oh, we see plus 1 in the parentheses. Well, then I know x is going to equal negative 1, because negative 1 plus 1 is 0. I can look in these parentheses. I can say, oh, x plus 2 equals 0. Well, if we see a plus 2 in here, we know one of our other solutions is going to be negative 2. So those are our two solutions. And if I wanted to write them from least to greatest, I would say minus 2, negative 1. But you could have negative 1 and negative 2 in that order. So those are our solutions. Again, if you wanted to break it up and solve it, x plus 1 equals 0, you would get negative 1. If you said x plus 2 equals 0, your solution would be negative 2. So those are your answers for number 2. All right, number 3 is going to look a little bit different. So this is a tough one, okay? So we see that we already have a trinomial in the form ax squared plus bx plus c over here, where b is negative 10, okay? So we already have it in that form, but we don't have 0 on the right side. Now, if I subtracted 27 on both sides, instead of plus 25, it would end up being minus 2. And then we would get 0 on this right side. But the problem is, I cannot factor this. I'm not going to get anywhere by trying to solve that, because I can't factor it. However, I can factor the left side. Okay? Even though the right side does not equal 0, I can factor the left side. Well, what are the factors of 25 that would add up to negative 10? Well, they're negative 5 and negative 5. So x minus 5 times x minus 5 equals 27. Well, we can rewrite x minus 5 times x minus 5 as x minus 5 squared. And that equals 27. And then I want to get rid of that exponent of 2. So again, I'm going to square root that junk on both sides. So we're going to get x minus 5 equals the square root of 27, which, let's go ahead and simplify this radical since we can. The square root of 27 simplifies to 3 times the square root of 3. If you don't understand how I got there, you can ask me in tutoring, or you can Google the topic simplifying radicals, or look it up on YouTube. It will help you. But I missed one thing here. When I took the square root of the right side, I did not include that positive or negative sign, okay? Because we should have two solutions here. Positive and negative, 3 times square root of 3. X is still not by itself though yet. We have still not isolated x, so I'm going to add 5 on both sides. And I'll cancel it out. And I'm going to move up here to the top. So I'm going to get x equals 5 plus or minus 3 times the square root of 3. That's two different answers. 5 plus 3 times the square root of 3 and 5 minus 3 times the square root of 3. Those are two different answers. You could put that in your calculator, 5 plus 3 times the square root of 3, and get a numerical value. And you can put 5 minus 3 times the square root of 3, and you get another number. Okay, so that's two solutions. So I hope that video was helpful for you. I know it was helpful for me to be up in front of the board, and I enjoyed that, and also get to spend less time editing. But yeah, make sure that you come to class prepared to work and to sharpen these skills. If you feel a little overwhelmed by it right now, don't sweat it. We're going to get plenty of practice our next class. But good work today. Thank you, collegiate scholars.